Our next guest is a world-renowned physicist and best-selling author whose latest book is entitled The Fabric of the Cosmos. Ladies and gentlemen, here's Brian Greene. I have no knowledge of what you're going to talk about, so please, I'm begging your patience and indulgence. Tell us about the string theory. That's one of your specialties. Is that correct?
That's right. So Albert Einstein, for the last 30 years of his life, sought what he called a unified theory of physics. That would be a single equation, a single idea, a single principle that might describe everything in the universe. And he never found it.
Is that reasonable, to have one theory that explains everything?
It's a good question. We don't know for sure, but the progress of science has been a winnowing down of a variety of explanations that work here, there, or someplace else to one more powerful explanation that describes more and more phenomena.
That would simplify everything, wouldn't it?
It'd be great. Imagine we had one equation that could tell us how the universe began, how it evolved to the form that we see. It would be amazing.
So is this it, then, the string theory? Is that what he was unable to put his finger on?
I don't know.
Your witness.
I hope it is.
All right, well, now, try and explain to me the string theory.
The basic idea is to rewrite the rules of what matter and energy are made up of. So imagine you take a powerful microscope and you magnify this tabletop so that you can see the inner workings, the things that make it up. We all know that if you magnify it enough, you get to atoms. But we know that atoms are not the end of the story. They have little particles, electrons, that go around the nucleus, which has neutrons and protons. And there are even particles inside of those, known as quarks. That is where the conventional ideas stop. String theory comes along and suggests that there's another layer that so far nobody thought of. Inside an electron, inside a quark, inside any particle is a little filament, kind of looks like a string. And this little filament is a filament of energy that can vibrate, like the string on a violin vibrates in different patterns that your ear senses musical notes. These little strings vibrate in different patterns that produce the different particles. So every particle arises from the different vibrations of this new entity, the string. That's the unification. Everything comes from one thing.
And how, then, does that resolve all the other heretofore unresolved questions about existence?
Well, it's a big question, but the previous problems were that Einstein's ideas of how gravity works, his general theory of relativity, and the other theory of the 20th century known as quantum physics were at loggerheads. They each said the other was wrong, even though each worked in its own domain. String theory finally describes a universe in which those two ideas are put together, stitched together into one framework, and we think it makes sense.
Right. So how is my life better for this? Just looking at it very selfishly, what do we now know we didn't know before?
Well, a big question is, how did the universe begin? And we cannot answer that question. Some people think that the Big Bang is an explanation of how the universe began. It's not. The Big Bang is a theory of how the universe evolved from a split second after whatever brought it into existence. And the reason why we've been unable to look right back at time zero to figure out how it really began is that conflict between Einstein's ideas of gravity and the laws of quantum physics. So string theory may be able to, it hasn't yet, we're working on it today feverishly, it may be able to answer the question, how did the universe begin? And I don't know how it will affect your everyday life, but to me, if we really had a sense of how the universe really began, I think that would really alert us to our own place in the cosmos in a deep way.
And is this the kind of thing that you deal with all the time or not? Because is it likely that the more you know and the more you don't understand about the beginning of the universe, the more that builds a case for it being created by an all-powerful being? Or does that not figure in your science?
Well, science can never rule out the possibility that there was an all-powerful being, a god, if you will, that created the universe. You can never rule that out, but it's not a very satisfying explanation from the point of view of a scientist, because we want an explanation that really understands the nuts and bolts of how the universe began. You can ask any question and say, oh, God made it that way, and you can say that, but we have learned that if you look deeply, you can get more deep explanations. And we're hoping the deepest one will tell us how the universe began.
And is it possible, if you solve the question, you can then say, yes, here is how that all-powerful being created the universe? That would satisfy everybody, wouldn't it?
You could phrase it that way, and if that makes you happy, that is perfectly fine with me. But what I would say is, I don't know that you're going to need the all-powerful being. You can't rule it out, but we may have laws that, in and of themselves, may explain everything. It's possible.
Are you confident that in your lifetime there will be a viable, satisfactory explanation for everything in the universe?
Well, everything is a big subject, but I think, I think that we may be able to understand the basic ingredients that make up everything, the basic laws by which they interact and influence each other, and in that way we'd understand the universe at that very deep fundamental level. But can I predict what you're going to have for lunch tomorrow based on those laws? I doubt it.
Yeah.
It's hard to talk about things of such complexity with laws that are so fundamental.
Macaroni and cheese.
There you go.
Now, when Einstein was doing his work, was it that he was so brilliant or he was one of the few working in that area at the time? Are there many guys, are you like Einstein now? Do you have the qualifications that he had?
No.
Yeah. Are there guys like Einstein now doing the same work?
There's really nobody out there today who I think really compares to the genius of Einstein. I mean, in 1905, we're now celebrating the 100th year anniversary, Einstein wrote 4 papers that changed our understanding of the universe. 4 papers that any of us would be happy to have written half of one of those papers.
What are the 4?
Special relativity, space and time not what we think they are, E = mc squared, which we've seen the consequences of in many ways in our everyday life and in the universe at large. The existence of atoms, he proved, through Brownian motion, it's called. And the most important paper was on something called the photoelectric effect, which launched quantum physics.
Wow.
That is the paper he won the Nobel Prize for, not for relativity.
And what about that wait a half hour after eating before going swimming? Was that, was that Einstein or... why do I even... I don't know. All right. And what about the notion of time travel? We can't do that, can we? Is it possible, but we can't do it?
We can absolutely travel to the future, and I don't just mean we each age. If you want to see what things are like 1 billion years from now on planet Earth, Einstein laid out a blueprint. He showed us how to do that.
Really?
You build a ship that goes near the speed of light. We can't do that yet today. That's a technical detail. But if you build a ship that could go near the speed of light, you travel out for 6 months, you turn around, you come back, you've aged 1 year, 6 months, 6 months, but because of your incredible speed, time slows down for you relative to time for everybody else on planet Earth. So when you get out of your ship, you'll be 1 year older, but people here will be 10,000, a million, or 1 billion years older, depending on how close to the speed of light you went.
Wow. Wow. And is that a likelihood ever?
That is hard to answer. You know, technology grows by leaps and bounds. I don't know. But the thing I would stress is this is not controversial from the point of view of how time behaves. People have taken clocks, atomic clocks, the most accurate ones in the world, put one on the ground, put the other on a jet, a Pan Am jet. You know, Pan Am used to have these planes. And they flew that jet around the world, and then they took the clock off and compared the clock that was moving with the clock that was stationary, and they differed by exactly the amount that Einstein said they would. It's only a few billionths of a second, since planes don't go that fast, but this is established fact. This is not controversial.
Wow. Does your head ache all the time? Is it just... Does any of this make sense to you? I appreciate you putting up with me, but I'm just as dumb as they come. But this is it. This is the book. It's called The Elegant, The Fabric of the Cosmos. The other one was The Elegant Universe. A pleasure listening to you. Thank you very much. Brian Greene, ladies and gentlemen. We'll be right back, everybody.